Active learning is a powerful technique in the field of computer vision that has gained significant attention in recent years. It refers to a machine learning approach where an algorithm actively selects the most informative samples to annotate and train on, instead of relying on random sampling or pre-selected data points. In this part of the course we explore the various applications of active learning in computer vision and how it can improve the efficiency and accuracy of computer vision systems. Semantic segmentation. Semantic segmentation is a fundamental computer vision task that involves assigning a label to each pixel in an image. Active learning can play a crucial role in this task by selecting the most informative pixels for manual annotation. Instead of annotating the entire image, an active learning algorithm can choose the regions where the model is uncertain or likely to make errors, thereby reducing the annotation effort required and improving the quality of the segmentation. Object detection. Active learning can also be applied to object detection, which involves identifying and localizing objects of interest within an image. In this scenario, the algorithm can select the most challenging or ambiguous image regions for annotation. By focusing on these regions, the algorithm can learn to better distinguish between different object classes, resulting in improved object detection performance. Image classification. Image classification is a classic task in computer vision that involves assigning a label to an entire image. Active learning can be used to iteratively select the most informative and labeled images for annotation. By actively querying the labels of these images, the algorithm can gradually improve its classification accuracy, reducing the need for manually labeling a large number of images. Anomaly detection. In computer vision, anomaly detection refers to the identification of rare or abnormal events in a given dataset. Active learning can aid in this task by selecting the most anomalous or uncertain images for manual annotation. This helps in building a robust model that is capable of accurately detecting and flagging anomalous events, which can be particularly useful in surveillance systems or quality control applications. Image retrieval. Active learning can also enhance image retrieval systems. By selecting representative images from the unlabeled dataset for annotation, the algorithm can learn to better capture the most relevant features when searching for similar images. This can significantly improve the accuracy and efficiency of image retrieval tasks. Semi-supervised learning. Semi-supervised learning is a learning paradigm that combines labeled and unlabeled data during the training process. Active learning can assist in selecting the most informative unlabeled samples for annotation, enabling the model to leverage the available unlabeled data and improve its performance. This can be especially beneficial when labeled data is scarce or expensive to obtain. Conclusion. Active learning has emerged as a powerful technique in computer vision with various applications. By selectively choosing the most informative samples for annotation, active learning reduces the manual labeling effort and improves the performance of computer vision models. Whether it is semantic segmentation, object detection, image classification, anomaly detection, image retrieval, or semi-supervised learning, active learning can enhance the accuracy and efficiency of computer vision systems.